up to this point in this course, we always built projects locally. We tested them locally on an address like localhost 8080. We had our local development server running in our projects to test the code we wrote, to see our application in action. And that, of course, is totally normal during development. You do develop locally on your machine. But of course, ultimately, your goal is not to have your Vue application locally on your computer, but you want to deploy it. You want to bring it onto other servers and share it with other users. And therefore, this module will be about deploying and optimizing Vue apps so that we can get from development to production. And you will learn what exactly deployment means and which files you need to upload where to share your Vue app. We will have a look at optimization techniques or deployment steps, you could say, and we'll see all of that in action at a concrete example. Now, what does deploying a Vue app actually mean? For this, it's important to keep in mind that Vue apps run in the browser. I mean, any website is loaded with a browser, but Vue apps are driven by browser-side JavaScript code. All the code we're writing here, in the end, is transformed by this project setup and then converted into JavaScript code, which our browser understands. So what we see on the screen here was loaded from a server, but it was rendered on the screen by Vue, by this JavaScript code we wrote, and that happened entirely in the browser, not on some server. A server was just serving this HTML file, this HTML skeleton, and then the JavaScript code, which again was then executed in the browser, not on the server. And I'm emphasizing this because this influences how we deploy a web application, a website. Here, we really just have a couple of files which are all interpreted by the browser. We got our HTML files, in this case just one HTML file since we're building a single page application. We got CSS files, possibly. Here in the projects we worked on, we didn't have separate CSS files. We merged that with the components, and therefore the project setup will take care about extracting this and adding it to the page. We have no separate CSS files. And most importantly, we have a bunch of JavaScript code. Here, for example, we have our project setup, and that project setup will have certain scripts for transforming the code we wrote to code the browser understands. And I'll show you these scripts throughout this module. But therefore, we just have HTML, CSS, and JavaScript. We have no code that would run on a server. And therefore, we have a static web app, a static website, which means it's just a website with code that is evaluated by the browser and has no server-side code. And hence, a static website hosting provider is all we need. And options here would be AWS S3, Firebase hosting, Netlify. There are tons of static hosting providers. You can just Google for static hosting provider and you'll find a couple of examples. So that's what we need, and I will show you an example and the full deployment process step by step throughout this module. Now, as a first step, before we upload anything anywhere, we want to finalize our code. We want to polish our code and make sure it's optimized. That, of course, means that we want to test it. We want to test different scenarios and find possible errors in the code and fix them. We also might want to consider refactoring our code so that we don't repeat ourselves too often or that we solve a certain problem with less code. Because the less code you have, the less code the users of your website have to download before they see something on the screen. So less code means faster websites. And there's one specific optimization technique which I want to take a closer look at, and that would be asynchronous components, which are supported by Vue. Now, what is that? What are asynchronous components? I'm taking this course project, which we built earlier in this course, and you find that code snapshot attached in case you don't have that at hand. Here we have a bunch of components, a couple of components which we load as pages through the Vue router, and a bunch of code in general. Now we can definitely test this and we can definitely refactor some code, but that's not what I want to focus on here. Instead, I want to focus on that async component approach. What do I mean with that? Well, there are certain components which we don't need every time this application is loaded. A good example could be that dialog which we see here during login. When we log in, we need it. But in the rest of this app, we don't use it too often, so we might not always need the dialog component. And the implication of that is that we don't necessarily need to download the source code behind that component all the time. Because as I mentioned, if users visiting this webpage have to download less code, that means the website can be used earlier. You don't have to wait for as much code to download. So the dialog could be a component which we can load lazily, asynchronously, only when we need it, and not in advance. Because right now, all those components, all pages and all other components are downloaded all the time, no matter if a user needs them or not. And that means we have everything available when we need it. That's great, but it also means we download a lot of code in advance which we don't need yet, or which we might never need. And a similar example could be found for many routes here. The register as coach route, for example. For this user, since I already am a coach, I can't even visit it. So I definitely don't need the code for that. And that is something where Vue can help us. And let's start with that base dialog, which we don't need all the time. In main.js, we register this base dialog. We import base dialog from this file and we then register it. Whenever you have an import statement like this in the end tells Vue that the code in that file you're importing is needed. And you can imagine that all these imports are in the end, when you build your project, when you finalize your project, all these imported files are basically merged into one big file, kind of. That's how you can imagine this. So therefore, it would be great if we wouldn't import this. If we would only import it when we need it, then it would not be merged into this big file, but instead Vue would try to download the required code only when it's needed. And for that, Vue has a function we can use, the define async component function. With that, we can define a component which is loaded asynchronously, only when it's needed. Here we could then create a constant named base dialog so that I don't have to change the name down there. And the value I store in there is the result of calling define async component. Define async component wants a function. And here I'm using an arrow function. It wants a function that in the end then returns the imported component. But Vue will only call that function when the component is really needed. So here I can use the shorthand notation of arrow functions and call import, which also exists as a function like this in JavaScript. So it's not the import statement we have here. Instead, now I call import as a function. And when we call import as a function, that will only do that import when the surrounding code executes, which in this case is this function we pass to define async component. Well, and this function is executed by Vue only when that component is used when it's needed. And with that, we ensure that the code of the entire base dialog component is only imported when needed. Now for that, we still need to provide a path to that component here to import though. But now with this dynamic import, we don't import it in advance, but only when it's required. And now we can still assign base dialog as a component here for base dialog, and Vue will know how to handle that when it needs to bring a dialog to the screen. So if we save that and reload, if I log out and log in, like this, we still see the dialog, so that still works. But actually the code is only downloaded when it's needed. And I can prove this to you. If I log out again and go to login and reload there, we can open up the DevTools, ignore the warnings here, and go to network. And now if you reload again, you see a couple of files that were downloaded from our development server. And one file you see here is this 0.js file. Maybe it's named differently for you, but you should see an extra JavaScript file next to app.js, which is your main app, and maybe this chunk vendors.js file. Now, if I log in, you won't see any changes in here, but if I now go to register as coach, if I now clear this network log and reload, you still see 0.js, but you see it only once. If I now clear this again and go back to all coaches, you see now here, that's where this file is actually downloaded. And 0.js, in the end, holds the transformed code for this dialog. Hard to tell if you look at this code here, but that is what you'll find in there. You see some hints at it here, like this name. So what I want to show you now is that Vue now checks the template of the components you're currently working with. And if none of those templates uses the dialog, it doesn't download the dialog. And the coach registration component doesn't use the dialog. Neither does the coach form or any other child component there. That's why here, if you're on this part of the app, Vue won't download the dialog. On the other hand, for the all coaches page, it does download it, because here on coaches list, we do use the base dialog. And that's a pretty neat feature. Now regarding that warning which I'm getting here, this might just be a bug by Vue at the moment, because everything seems to work correctly and we are definitely using the fine async component correctly. Now we cannot just use the fine async component for global components like this though. We can also use it for local components and that's pretty interesting, for routes. Because here we probably got the biggest code splitting potential. If we never visit a certain route, fetching all the code for that route component and all the child components there is really redundant. So therefore here we can also use this define async component function. So we can import from Vue this define async component function here inside of router.js. And then we can replace the routes which are maybe never visited with asynchronously loaded components. For example, coach detail. Maybe a user never clicks that detail button. So then we can also set coach detail equal to define async component, passing a function to it, calling import there, and then pointing at this path. And then we can comment out this static import here at the top and just work with the dynamic one. We can do the same for, let's say, the coach registration. And that should be coach registration, as I see. We can also grab this here, call the define async component, and import this dynamically, so that if the user never visits the coach registration page, we don't bother loading the code for it. So we can comment this out as well. And we can do this for all those components, or for most components, it makes sense, I would say. For a contact coach, for example, maybe a user never sends a contact message, well then we don't need to load the code for that component and its child components. So that's another component we can turn into an async component. And why don't we do the same for requests received? Maybe this page is never visited. So therefore here, we can also load this lazily, asynchronously, and not all the time. So let's comment this out as well. And the same for auth. If a user is authenticated and reloads the page, we don't need to load the auth page again. We won't need it. So we can copy that and also load this lazily with async components. And comment this out as well. And you might find more places where this makes sense, but I will go with these components. And now also change the code registration name, which I mistyped earlier. And with this, if you save this, what you will notice is if you open the network tab, you see a bunch of chunks are downloaded here. You can ignore these chunks up here. You see only 0.js appears twice. And that's then the only extra code chunk which is really downloaded. So only 0.js appears twice. But for example, if I click on requests, we see 1.js was downloaded. So looks like this was the code for the requests received page. If I go to register as coach, we see another code file was downloaded. So now really the files are only downloaded as we need them. And that of course is very useful, because with that we can download a slimmer initial bundle and then only download the extra component code as we need it. And that's the idea behind async component, and that's therefore a key optimization step you should be aware of, especially when it comes to routing. So let's say we now optimized our project. We fixed all errors, we refactored the code, and we added asynchronous components. Now we got our Vue project finished up and we want to upload it onto some static host. Now we have to differentiate between two kinds of projects. If you have a very simple project, as we had it in the beginning of the course, for the Monster Killer project for example, we really just had a couple of custom HTML, CSS, and JavaScript files. We had no project setup created with the Vue CLI or anything like that. In that case, you can just grab those files and upload them onto a server. If you have a project that's a bit more complex, like the one we've been working with over all the last modules, typically created with the Vue CLI, then you have a couple of other steps. You want to optimize your code as shown, so let's say we did that, but then you need to build your project. And this will then also automatically optimize your code even more, automatically for you without you doing anything for that. Building your code is required because the code we got here, with all those .vue files, that is not code the browser would understand. That's code which needs to be transformed into regular JavaScript code first. And the CLI created projects have a built-in script which you can execute, which will do that transformation. And only once you got that built and optimized code, only then you will have a couple of files which are generated for you, which you can then take and upload onto a server. And it's therefore this second part, this right part of this slide, I want to focus on, of course. So let's now build our project. To build your project, projects generated with the Vue CLI will have scripts you can execute. In package.json, you find all the scripts you can execute. And thus far, we always used the serve script to bring up that development server and test our application. Now we need the build script. That will do what the name implies. It builds the application and it builds it for production and optimizes it for production. And we run this script in a terminal navigated into this project folder by running npm run build. And this will now go through all our code, bundle it all into all those files we need, one big app file, and then these smaller chunk files for the async components, and it will transform the code into code the browser understands and optimize it to make it as small and efficient as possible. And once this process is finished, you will find a dist folder. And that dist folder now contains your single page, the index.html file, and then a JavaScript folder with all those code chunks with highly optimized JavaScript code, as you can tell. and a CSS folder with all the generated CSS files with the CSS rules, all minified and optimized to take up as little space as possible. And it's the content of this dist folder which you now need to put onto a static hosting server. So that's what we're going to do next. So let's deploy our dist folder content. And I mentioned that there are many options for hosting static web apps. AWS S3, Netlify, Firebase hosting. I will go with Firebase since we've been using that in earlier parts of the course already. So you probably have a Firebase project by now, and hence hosting will be easy to set up. You can simply click on hosting in your project, and you could also create a new project for hosting. It doesn't have to be the same one as you have for your Firebase database, just as a side note. But here I will use the same one, and I will click on hosting, and you'll find instructions here, but in the end, hosting is really simple. If we click on Get Started, we see that we first of all need to install an extra tool. Okay, so let's do that. Let's run this command. On Linux and Mac OS, you might need to add sudo in front of it. On Windows, you don't need to do that. So run this command, and this will then install an extra tool provided by Firebase globally on your machine, and we'll need that tool to then upload our project later. So let's wait for this installation to finish. And once it is finished, we can go to the next step. Now we need to log in by running Firebase login. So let's run this. And this should open up a tab in the browser and allow you to log in if you're not logged in already. Or it prompts you for password and your username, your email address, and you have to log in with those credentials which you used for logging in into your Firebase account before as well. Once that is done, you need to run Firebase init. So copy that command, and now in your project folder, in your entire project folder here, you can run Firebase init. And this will ask you a couple of questions. It asks you which part of Firebase you want to manage with this command line interface we're using at the moment. And we really only want to use hosting here, so select hosting with the arrow keys and press space to mark it, and then enter. Now then you're prompted whether you want to host this into an existing Firebase project or create a new one. As I said, you could create a new one, but I will use an existing one. And then it should list all the projects you have. And I'm simply picking that project with which I worked earlier already. Now we have the interesting part. It asks us what our public directory should be. And that's important because that's the directory which holds the files that will actually be uploaded. So here, that would be the dist folder. So we should enter dist here. Once you entered dist, hit enter, and you're asked whether this should be configured as a single page app and rewrite all URLs to /index.html. Now that can be confusing. Why does this matter? What's this about? For single page applications, you have to be careful when it comes to routing and hosting your app on a server. When a user visits your webpage, let's say it's hosted on a domain like mypage.com, a so-called request is sent to the server. Now let's say that request is not to your main domain, but it's mypage.com/products or anything like that. Now, as I just said, that request hits the server where your static web application, your Vue single page application, is hosted at. Now, this server should actually ignore the path that's part of the request, because if it does not ignore it, then the server will try to find something on the server that matches this request. For example, it looks for a products folder in your hosted files and tries to find an HTML file in such a products folder. And for our app, that would fail, because for our app, the folder structure we deploy is this. we have just one HTML file. In our app, for example, we have a /coaches route, but we have no coaches folder here inside of dist, which is the content that will end up on a server though. That's why we need to tell the server to ignore the path and instead always return the index.html file, which then in turn contains the JavaScript code of our application, where then the view router can take over and handle this path on the client side. So in the browser. And that's really important. The view router does not run on a server, and therefore it can only handle the path which is in the URL if the server ignores it. The development server was already configured to work like this, which is why we didn't have to worry about that before. But web servers, real web servers, typically do not ignore it by default. And that's why Firebase is asking us here if we want to configure this as a single page app. If we choose yes here, which we should, then Firebase will ignore all requests on the server and, as mentioned here, rewrite all URLs to index.html so that always index.html is served. So let's choose yes here. And now it tells us that we already have an index.html file in dist, if it should overwrite this. And here we want to enter no, because we want to keep our file. And now with that, we initialized everything. Now to really deploy this, there's just one change I want to make. In the public folder in index.html, we can edit the index.html file before the project is built. So any changes you want to make to your project, to your HTML code in here, for example, should be made here, not in dist. You should never touch the code which is generated in the dist folder. Instead, edit your input files and rebuild the project if you want to have a different output here. And here, for example, I want to edit the title. It's actually using a placeholder here, in the end pulling in the title from somewhere else. But we can delete this and overwrite this with find a coach, for example, which is my title. And now we could also add a meta tag with a name of description to then also add a description for search engines, like find a coach and grow as a developer. And now with these final tweaks made, I will run npm run build again so that these changes are picked up and reflected in the dist folder, which is now recreated. And now we configured Firebase, we have the final dist folder, now we want to push the code onto Firebase. And that's done if we follow the Firebase instructions by now running Firebase deploy. So now we do that, run Firebase deploy, and this will now take our code and upload it onto Firebase. Now, it shows us a progress here. Let's wait for this to finish. And once it's done, it also gives us the URL where we can visit this app. So I'm going to copy that, open it here. Well, and here is the application which we built before, now running on a real web server. Now, it will be offline when you're viewing this, but you can try it on your own with your own project. And for anything else you want to configure, like a custom domain or anything like that, check out the Firebase console. There, once you deployed your app under hosting, you can see your app, you can add a custom domain, and you can do a bunch of different things here to fine-tune this to your requirements. And that's it for deployment. These are the steps and core concepts you should keep in mind when you want to deploy Vue apps to a real server. In this course module, we are going to explore the biggest addition Vue Free introduced, so the biggest change from Vue version 2 to Free, in case you're interested in that. We're going to explore the Composition API. The Composition API gives us a different way of building our components, of writing our component code, but I will already say not a totally different way. The template, the styling, that stays the way it is. The props and custom events concepts, that stays the way it is. The JavaScript code you write, that however changes if you use the Composition API. And I will also already say the Composition API is 100% optional. You don't have to use it. I'm not teaching you everything I taught you thus far in the course just to now tell you that it's obsolete. No, what you learned thus far is the basis of Vue and absolutely fine. But you can move to this new Composition API or even mix it with what you learned thus far if you like to. But with that, let's get there step by step. In this module, I will start by explaining what exactly the Composition API is and why it exists, why we have these two different ways of building components. We'll then understand the Composition API. We will learn how to work with it and how to write code with it. And of course, I will show you how you could move from the Options API, which is the name of the approach we used thus far in the course, to the Composition API if you wanted to. So let's dive in. What exactly is the Composition API? Well, let's start with what we learned thus far. When it comes to building Vue apps and Vue components, we thus far used the so-called Options API. We created this configuration object, and in there we configured various options. For example, the data option, the methods option, but maybe also computed or watchers. So we had this configuration object where we set up our data, our methods, so the code we could run upon events, for example, and so on. And I will emphasize it again. This approach is absolutely fine and you can stick to it. It's not bad, it's not a second best option. It is absolutely fine. And knowing it is actually a requirement for understanding the Composition API, I would say. But what is the Composition API then? This is the Options API. The Composition API is an alternative way of writing the logic behind our components. And it was introduced because we might, and I'm saying might, face two main limitations or issues when building bigger Vue apps. In smaller and medium-sized apps, we will very likely never face those issues, but in bigger apps, we might face them. Issue number one is that code that belongs together logically is actually split up across multiple options. Data, methods, computed, for example. And I have a little example project here. You don't find it attached here because we're not going to work with it here. I just want to show it to you. Now in this demo app, which brings this to the screen where we can sort various users, filter for users, and view the projects of our users, and also filter those projects. In this app, I'm using a couple of different components which together form this user interface. And this app is built with the features we learned over the last modules in this course. In all those components, I'm managing data, I might be getting some props, I might be registering more local components, we get some computed properties, some methods, some watchers. And that's not just the case in this one component, but in multiple components. Now, coming back to that first problem I brought up here, that code that might belong together logically is split up across data, methods, and computed, so across these different options. That's something we can see in this demo application. In the user list component here, for example, I have some data that is related to searching and other data that is related to sorting. I got a computed property that deals with searching and then one that deals with sorting. I got a method that deals with searching, one that deals with sorting. Got a watcher that deals with searching, and so on. And that's what I meant with features that belong together are split across these different options. Now, this is definitely not a horrible problem, and this is definitely not a super huge application, but it is an application where this component already could become a bit annoying to manage, because if you change something about searching, you might have to change it here in data, then change something here in the computed property, change something here in methods, and you have to scroll around a lot and find the different pieces that together make up the search feature. Because the different pieces that make up that feature are split across various options. But that's not just the only issue we could be facing with the current way of building Vue apps. In addition to the problem I just described, reusing logic across components can also be tricky or cumbersome. Now, I will say there are ways of reusing logic, but they all have their downsides and might not be ideal. And in this demo app, there is logic that could be reused. Both in the user list as well in the projects list component, I have my search functionality. And I have similar computed properties and similar watchers. And it would be nice if we could reuse some logic here so that we don't have to write almost the same code twice in two different components. Well, and these are the problems we could be facing in bigger Vue applications with the current approach. Not technical problems, and maybe not problems at all to you. Maybe you're absolutely fine with that, but maybe things you would like to get rid of. And that's exactly where the Composition API can help us. Instead of writing code like this, where we split our logic across multiple options, that's also why this API is called the Options API, we instead bundle our logic in a new setup method, which we add to our component config object. The setup method is added next to data and methods and so on, but it will actually replace data, methods, and so on. And we will manage our data, our functions, our computed properties, and our watchers in that setup method, where we then also expose them to the template so that we can interact with those things. And that's, by the way, important. The template code we write, features like VIF and data binding, and all of that stays exactly the way you learned it. It's just how we set up our code in this object, in this component config object. That is what will change a bit when you switch to the Composition API. Because we're going to merge, you could say, these four main options, data, methods, computed, and watch, into this setup method. But with that, we got enough theory. Let's now dig into the code and see how we actually get started with the Composition API. So let's now dive into the Composition API. I already mentioned that we're talking about data, methods, computed, and watch, that we're talking about these four options from the Options API, which will now be handled differently in the Composition API. These four options are in the end going to be replaced with code we're going to write in the new setup option, a new setup method we can add to our object, our component or Vue app configuration object. On the other hand, that means that all the other options we also learned about, props, emits, components, those remain untouched by the Composition API. So there, nothing changes. What you learned about these options does not change. The only other part which will also change, which is not on this slide, will be the lifecycle methods, but I'll come back to those later. Now let's start with data, and let's see how we replace data with the Composition API and this setup method. For this attached, you find a very simple project. It just has one app Vue file at the moment, which is also very simple. I'm just outputting a username here, which for the moment is hard-coded into my data option. But it's still the data option, so we're not using the Composition API yet. Got some styling here, and if you install all the dependencies and then start your development server with npm run serve, You see this here on the screen. Now let's see what the equivalent to this data option would be if we use the composition API. And therefore I'll comment data out, and instead the first thing I'll do is I will add the setup method. This is this new method we can add since Vue version 3 in our component config objects. And again, if we had something like local components registered in the components option, or if we had props here, that would remain untouched. That would stay here. But we now added setup, and now the goal is to replace the data we managed here, so username, with something new so that we still can output it in the template. And there we got two new features offered by Vue that help us with managing data. We need to import them from Vue, so we need to add an import statement to import something from Vue. And the something which we put between the curly braces here is ref. Now this is an import syntax which imports one of many things exported by Vue, and here we're importing ref. Now what's ref? We learned about refs earlier in the course. For the moment, let's ignore that. Ref is slightly related to what we learned about refs in the past, but still, on the other hand, it's something new. So let's ignore what we know about refs thus far. It's a different concept here. Because ref is a function which we now can call inside of setup. And ref creates a so-called reference, but now not just a reference to some DOM element, but instead a value which we can reference, which we can use in our template, for example. So ref creates a value, but not any kind of value, instead a reactive value, where Vue will find out when we change it, where Vue is able to watch it, and where Vue then is able to update the template and the DOM when that value changes and is being used in the template. But ref like this actually does nothing. It creates a value, as I mentioned, so we should store it in some variable or constant. And we are not going to use the this keyword here, because whilst it technically would be available in the setup method, since this is still a method in this object, this here is actually not referring to the Vue config object as it does in methods, for example, because setup is a method executed by Vue very early during the component initialization process, at a point of time where this component hasn't been initialized yet, and therefore this actually won't give us access to all the things we're used to. It doesn't give us access to props if we had any, and so on. So we don't use this here in the setup method, and we're not going to store this value in a property of this overall config object. Instead, we're just going to store it in a plain vanilla variable or constant, and here I'm going for a constant, and I will name it username. So now the ref thing here is stored in this constant. Now I said ref creates a reactive value, but what is the actual value here? We might want to store a number, or in this case a string, our name. Well, you can pass the actual value which you want to store as an argument to this ref function. So here I'll pass Maximilian. And this now creates a reactive string, you could say. Under the hood, it creates an object. This string is stored in that object, and Vue will watch this object so that whenever we assign a new value instead of that original string, Vue will be aware of it and is able to update the DOM. But step by step, at the moment, this code simply won't work. If we try to save this, we get an error that username is created but never used. And it's true, we have that username constant, but we're not doing anything with it. You might think that we're using it here in the template, but actually that's not how it works. It was the case with the Options API that you had access to all your data properties, your computed properties, and your methods in the DOM just like that. This is not the case for some constants you might have in your setup method. If you have a constant here, it's not available in your DOM, in your template. Instead, you need to do one extra step. You need to return what you want to expose to the template of this component this config object belongs to. And you always return an object here. So in setup, you return an object. And into this object, we'll put all the things we want to expose to the template. So here, we want to access a username thing, and therefore in this returned object, we should add a username key. And the value we want to store under that key is the value stored in this constant, which is also named username, but we could have chosen a different name here. And to avoid confusion, let's maybe name this uname, and therefore also name it uname here. So here I'm referring to this constant, here I'm naming this username because I'm accessing username in my template. And what I expose in this returned object is now available in this template. And if I save this now and reload, everything works and we see Maximilian here on our page. So that's how we create and store a value with the composition API. We use this ref method. Now, actually, you wouldn't even need the ref method. If I remove it and I store a normal string here, if I save that, I get an error that I'm importing ref and I'm not using it. So let's comment out the import real quick. But then if I save that, that also works. So why do I need ref then? Well, because I already said that this, if we create it with ref, would be a reactive value. And that's the next thing I want to show you here. Let's say we have a timer here. We use set timeout, which is built into the browser. And after 2 seconds, we execute a function here. And in this function, I want to assign a new value to my uname constant. Now here's how we're not going to do it. We're not going to say uname equal your new value. For one, that's not allowed because this is a constant. Of course, we could turn it into a variable, and now we could assign a new value, but now we would overwrite the old ref with a simple new string, so we would lose the ref. And we want a ref because the ref has some built-in mechanisms to let Vue know about changes to that value. Because if we do it like this, you will notice that if I save this and I reload, after 2 seconds, nothing happens on the screen. We always see Maximilian here, never Max. Now I do assign a new value to uname after 2 seconds, but this new value is never picked up by Vue. The setup method only runs once, so we never return a new object with the new value to the template. And that's exactly why we need a ref. And that's why we can use a const, because I'm never going to assign a new value to uname like this. Instead, we can use uname, which holds this ref, and access a value property. I mentioned that the ref function creates an object, and under the hood, that's an object with a value property. The value you pass to the ref function here is stored under that value property. And you can assign a new value to this value property in this uname object. For example, Max. And if you do that, then Vue will pick it up and will update the DOM and the template. You see, this changes to Max after 2 seconds. And that's why we use a ref here. It's a reactive value, and we can manage any value here. A string, a number, a boolean, whatever you want. Vue will watch it and will pick up changes to reflect them in the DOM, as it does here. Now, one word about the template here, by the way. You don't access .value here because Vue will automatically drill into that value prop if you expose a ref in your return object in the setup method. So here username points at a ref, and we need to use the value property if we want to set a new value. But if we pass our ref to the template, Vue will automatically read the value property. So in the template, you don't use .value, but just the ref as a whole, and Vue will do the rest. So now we introduced ref, which creates reactive values, which are values watched by Vue, where changes are picked up to be reflected in the template. Now let's add a second value. Let's say besides the username, we also want to output the age here. So for that, we can simply create a constant, for example, add a second ref with a number, for example, and now here I also expose age here in my object, and I'm using age as a key because I'm using age here in the template. And the value for age is UH. And if we do that, we also see the age here. And of course, we could now also change the age here in our timer if we want to. We can assign a new value after 2 seconds, so that if we reload, after 2 seconds, both the name and the age change. Now, since we have two pieces of data, name and age, which kind of belong together, we could also consider grouping them together. So here, instead of creating two refs with two individual values, we could create a user constant and create a ref here which holds an object. And in that object, we have a name, Maximilian, and we have an age, 31. So now we still have a reactive value, but now it's an object where we group the data together instead of having two separate values. Now we could expose the username by getting it from user.value.name. Keep in mind, user is a ref, therefore it has a value property, and the value holds the actual value we stored here, so the object with the name property. And here we have user.value.age. And here in setTimeout, instead of changing these two individual values, we now set user.value.name equal to max and set user.value.age equal to 32. And if we save that and reload, we see Maximilian and 31, but after 2 seconds, nothing happens. The data doesn't update here. Well, there is a reason for that. When you create a ref with the ref function, you get an object. View gives you an object. We can see this if we console log it here with console log. If I reload, that's our ref object. And there we got this value property in which we actually got such a proxy. You might know this proxy from the behind the scenes module we had earlier in the course. We also have a getter and a setter on this entire ref object. With those, Vue keeps track of read and write access to the value property. So that if you, for example, access user.value and you assign a brand new object, Vue is able to pick up this change. But in addition, if you pass an object as a value to ref, that object is also wrapped by a proxy so that Vue is even able to keep track of internal changes in that object. So for example here, when you drill into the object and you assign a new name and age, as we're doing it here. Nonetheless, as you also could see, Vue was not able to update the screen, even though I'm just telling you that it would pick up those changes. The problem is how we pass that to our template. Here, we also drill deeply into this object. With user.value, we access the object stored in our ref, and then the name and the age properties. And that's the problem we'll have here. Name and age, these properties in there, the values of name and age, so of those properties, are just regular strings and numbers. These are not reactive values. So therefore, whilst Vue will indeed theoretically be possible to tell that something changed about user, it does not understand that we're in the end exposing user to our template because we're drilling into user like this. So all it sees is that we expose a string and a number, and since it doesn't track those specific values, it's not detecting any changes there. Now, one thing we could do here is we could provide the entire user object here, so our user ref under a user key to the template, and output that there. If I, for example, add a paragraph here temporarily, I can output user now, because we're exposing this user key here. And if I do so, indeed, you will see my object here, and you see it also changed after 2 seconds. Here you go. And therefore, we could, of course, also output user.name or user.age here. So drill into this object here in the template, and now it would work if I reload. After 2 seconds, it updates. Because now I still drill into this, but only in the template. I pass the raw object, the raw ref object, to the template here in my return statement of the setup function. And that is what matters to Vue. With that, it gets this raw ref object. It has all the reactivity that's in this object, and it knows when we assign a new value, and it knows that we're using this in the template. So then it goes ahead, finds the places in the template where we use this object, and updates that code. And that is how we would use ref correctly with an object instead of separate values. But if you are working with an object, there actually is a better alternative to ref. Instead of using ref, which you could use like this, and of course, by the way, you could now delete all of that, exposing just the user would be enough. But instead of using ref, you can now also import the reactive function, which is also provided by Vue. Reactive is a bit like ref, but it's explicitly made for objects. So now instead of ref, we call reactive, and you still pass your object to reactive. But where ref worked with any kind of value, strings, numbers, and objects, reactive only works with objects here. So you must pass an object to reactive. And now reactive does one important thing. It doesn't wrap this with an extra object which has a value prop which then points at your value. Instead, it makes this object which you pass to reactive by wrapping it into a proxy, so that you can still work with this object as if you would have just that object without any wrapper. We can also see this soon when we see this console log. But that means that instead of accessing user.value.name and user.value.age, you now access just user.name and user.age. So we can skip this .value step because there is no wrapping object with a value property, since we already have an object here and we're using reactive. Now, when it comes to exposing, we still expose it as we did it with the ref though. We expose the entire object, we don't drill into it to give Vue the entire reactive object, and we can now delete those other properties we're sharing here. And then we can use user.name and user.age. So just as before, the key difference is that we now don't have this extra wrapper object with the .value property. So just to bring this back as a comparison, before, with those individual value refs, we had uname.value equal max, and we had uh.value equal 32. Now we directly work with our object as if it would be a regular JavaScript object, but it's actually reactive. So if we save that and reload, we still see that it changes after 2 seconds. Now, one note about our console log here, where I'm logging user, before it was this ref object with the value property and the getters and setters for value. Now it's this proxy object here instead, which wraps our object and which simply has these internal listeners to changes to our properties. Basically what I already covered in the behind the scenes module. And with that, I'll delete this console log and leave that code because that's it for now when we talk about managing reactive data. You got refs and reactive. Reactive is there for objects. Refs are there for all kinds of values, including objects if you're fine with this extra dot value access. It's up to you which one you prefer. If you're dealing with an object, you have the choice between reactive and refs. If you have anything but an object, like a string or a number, it's always a ref. It's also up to you whether you want to group data together into an object or manage data standalone as we did it before. There is no wrong or right way here. It depends on your preferences, the kind of data, what the rest of your team says, and in general, your application, of course. Now you know these two important data management concepts, though, for reactive data, ref and reactive. And with that, let's dig deeper and let's see what else we can do with the Composition API. Now, before we dig deeper into the Composition API, here is an optional lecture. And I really want to emphasize this. It's optional. You can skip this lecture for now, proceed with the rest, and come back to it later. I want to explore this reactivity concept a bit more to make sure we're all on the same page and there are no unanswered questions here. I hope I could make it clear how ref and reactive works, that they're very similar, but that I could also make it clear what the difference is. I logged both to the console, and I'll do it again here with the age here as an example so that we can again see the difference. So I'm logging UH, which is a ref, and user, which is a reactive object. And I need to import ref again for that. And if I do that, if I save this and I reload, here's our log. The first one here, that is our ref. You see it's an object with that value prop, and in that value prop the number is stored. And we have the getters and setters. The object, the reactive object, is a proxy wrapped around our object, and it has those extra handlers for dealing with data changes so that Vue is aware of them. Now, a common mistake or something which can be hard to understand is that these objects, the ref object and the reactive object, are reactive, but not the values stored in them, which is why we have to pass the entire user object here and not the name and age separated. Just to make this clear again, if I would pass username and age like this to the template, so if I drill into the user object here and I provide that on a name and age key, if we do this and then try outputting name and age here, that would work, as you can tell, but after 2 seconds it wouldn't update. It always stays at Maximilian31, and those changes made here aren't picked up. And the reason for that is that the entire object is reactive, but the values in those properties are not. And if we expose those values to the template, Vue thinks that only the values matter and not the entire object. Hence, it's just interested in changes to those values, and since those values are not reactive objects and not refs, it will never know about these changes. That's why we had to do it differently. Hence, I'm reversing this to go back to the old code, where I expose the entire user and access it in the template. But now back to this console log statement. Here we can basically see the problem if I console log uh.value and I also console log user.name and user.age. If I log these 3 things here, if I reload, you see 31, Maximilian, and 31 here in the console. And these are ordinary JavaScript values. These are not special objects, hence they have no watch mechanism attached to them. This is what would arrive in the template if we just return user.name or user.age in this object down there, what I did a second ago. And then it hopefully is clear that this will never change to Vue. It's just a string, just a number. It never changes. Yes, the object from which I extracted those values, that object changes, but I took a snapshot of those values before the change happened. That's basically what I'm doing here, and that's the problem. Now, Vue has helper methods here, which can help us with understanding what's reactive and not. it has a isReactive and a isRef function. And whenever something is reactive or is a ref, when you expose it to the template, updates will be picked up. Whenever that's not the case, updates will not be picked up. So here we can check if uh.value is a ref, and we can check if username, user.name I mean, is reactive. And if I do that, save this and reload, I get false twice. And that's just what I've been talking about over the last minutes or so. On the other hand, if I check the entire and the entire user object, instead of the nested properties, I get true twice. So whenever we expose the entire ref or the entire reactive object to the template by returning it here, changes will be picked up and reflected in the template. It's as easy as that. Now I'll remove this here, but it can be helpful to be aware of these helper methods in case you want to find out whether something is reactive or not. Now there actually also would be a way of making the nested values inside of a reactive object reactive as well, or turn them into refs to be precise. There is a toRefs function which you can import from Vue. And toRefs is a very simple function. You give it an object and it will then automatically turn all property values into refs. So with that, we could get our user refs by calling toRefs and passing user, so our reactive object, to it. You can pass in any object, by the way. And with that, you get back an object which now has a name and age property, but now the values in there will be refs. So now I could expose username by accessing userrefs.name and age by accessing userrefs.age. And we could use username and age in the template now, like this, username and age. And if I save this, I get an error related to which I'm not using anymore. So if I comment out here real quick, and ref is also unused now, and I get rid of the ref import, it now compiles. And now if I reload and wait for 2 seconds, the update is reflected. Because now, not just the object is reactive, but with toRefs, we also wrap the nested properties into refs, so that now we can also pass those properties, those property values directly to the template, because now they are refs. And as I mentioned, if you pass a reactive object or a ref to the template, then changes to that value will be picked up and reflected in the template. Otherwise, they won't. Now that was a lot of extra deep dive stuff. As I said, it's an optional lecture. You can come back to that later again in case it's not entirely clear. You won't need all of that all the time. I'm just a fan of teaching something thoroughly and diving deep into a topic to give you a chance of fully understanding what's happening behind the scenes and why we are doing something in a certain way. With that, however, I'm going to revert all that code here because it's not important for the next lectures and I don't want to confuse you with it. So let me get rid of all of that, get rid of the toRefs import, and go back to user.name and user.age here in the template. And now with that, let's leave this deep dive and instead see what we can do beyond data management. So we had a look at ref for single values and reactive for objects if we want to group values together and want to ensure that we can edit properties just like this and still maintain reactivity. Now, enough about ref and reactive. We're going to see more of that as we write more code with the composition API. But now let's actually come back to this simple slide here. We learned that the data that's managed with the data option can be replaced with ref and reactive. Now we also have methods computed and watch, which I mentioned would be replaced. So let's now move on to methods here. For that, let's say we have a button here on this page, and it will be a simple button with no particular styling. And there I'll say change age. And when we click it, I want to change my age here. So for that, of course, we can add a click listener. And now normally with the options API, we would point at a method here. We would add our methods option to this config object and then have something like set new age or any name like this. And if we then had a age data property here, like 31 initially, we would set this age equal to 32, for example. That is how we would do it with the options API, with data and methods combined. Now, we're using the composition API, and therefore we don't have data, and we won't have methods. But how can we then call a function, call some code to be executed when an event occurs? How do we bind click here? Well, of course, we could access user age and set a new value here. You might remember that simple JavaScript expressions like this are allowed, and therefore we could do that. So if I keep this code and actually remove this timer, because I no longer want to update name and age with that, so let's remove the timer. So if I save that now, we have that button and it works. But running all the code that should run upon button clicks and form submissions in the template like this is definitely not what we want to do. It's a good practice to not put too much logic into the template, and if you consider more complex examples like form submissions, where you also want to validate user input and maybe show alerts and so on, then this absolutely would not be an option. Instead, the solution is actually very simple, though it might look strange when you see it the first time. The setup method here is called when Vue sets up this component. It's called only once. And in this setup method, you basically define the data which should be available in your template. Well, you cannot just define your data here, you can also define the functions that should be available to your template. We can add a function here, set new data could be the name, and we can expose that to the template as well. It might look strange that we define a function inside of a method, but this is regular JavaScript code. We can create functions inside of functions. This is absolutely fine. And actually, with set timeout before, we did nothing different. There, we also had a function which we created on the fly here. That's also just a function defined inside of the setup method. So defining a function here is fine. And in this function, we could set user age equal to 32. And now the question is, how do we expose this function to the template so that we can bind it to this click event? Well, just as we expose data, we can add a new key value pair to this object which we return here in the setup method, and for example have a set age key and point at set new data, or set new age maybe, and change the name up here as well. And I'm not executing the function here, I'm just pointing at it. So I'm storing a pointer at this function in the setAge property in this returned object. And this returned object simply holds all the things you can use in your template. That may be data like our user object, but it may also be a pointer at a function. So now setAge is the key here, so therefore we can bind our click event here to setAge. And this will then trigger the setNewAge function at which we point in setAge. And therefore if I save that and reload, we can still change the age, but now with this exposed function. And that's really simple, but this is how you expose functions which you typically bind to click events, but which you also can execute just like that between interpolation, for example. That's how you expose them to your template. You define them in setup and return them in your object. And that's your replacement for methods in the end. Simple as that. And of course, it does not just work with a reactive object, but instead, if we would go back to using refs, so if I reverse this all and I go back to uname and uh and having two refs instead of one object, then of course, we can also update our data here with value equal to 33, for example. Now we just need to change the code we exposed to the template because I went back to using two individual values. So now we could again expose, let's say, a username and a age like that. Exposing these two refs, which are defined here, where one of them is changed here, through the value property, which is watched by view as you learned. And then in the template, we can use username and age to output both. So username and age here. And with that in place, if we save this, this still works and updating also still works. So that's how we can replace methods. Of course, you can define and return as many functions as your component might need in the template.